Hello students, welcome back to our chemistry online classes. So today's our topic in solid state is electrical properties. Electrical properties. So these electrical properties can be learned in a theory called band theory. Okay, band theory. Before that, solids can be classified into three types based on their conductivities. What are they? They are conductors, insulators and semiconductors. Come to the conductors. Conductors. In that conductors, metals are the good conductors of electricity, we know. So examples are metals like copper and aluminium. So here the diagram what you are seeing. If you learn this diagram, it is very easy to learn and to write in exam. So this band, these are types of bands. This band is called valency band and this band is called conduction band. And this one is called energy level. And the gap what is present between is called forbidden gap. The gap which is present between is called forbidden gap. So here in conductors, the valency band is partially filled. Okay, the valency band is partially filled and usually overlaps with the empty conduction band in such a way there is no forbidden gap. So the gap is always not, it is almost negligible. Okay, so almost negligible. As a result, what happens? The electrons from the valency band can move to the conduction band. So this results in conductivity in metals. What I said? So the gap which is present between this valency band and conduction band is almost negligible. Eg means energy gap. Eg means energy gap and this gap is called forbidden gap. So the electrons which are present in valency band, they are partially filled. Okay, as they are not having much gap between this valency band and conduction band, the electrons can easily move from valency band to conduction band. So as a result, they can conduct electricity. So these conductors mainly depends on valency electrons. They should have valency electrons. And not only that, they can conduct electricity both in solid and in molten form. Understood? They can conduct electricity in solid and molten form. And next comes to insulators. Insulator examples I have taken non-metals. For that example, you can take plastic or rubber. Same, this one is energy level. This is valency band, conduction band. Okay, valency band and conduction band. Here you can see the energy gap. Eg is very large. Okay, Eg is very large and valency band is full. Valency band is full. So here, as they are insulators, the valency band is full of electrons. If you want to move the electrons from valency band to conduction band, we require lot of energy. High energy is required to excite the electrons from valency band to conduction band. So that is why it is not easy to conduct electricity in insulators. A huge amount of energy is required. So practically it is impossible to provide this huge amount of energy to excite electrons from valency band to conduction band. That is why insulators are bad conductors of electricity. Next comes to semiconductors. Example, silicon, germanium, you can take arsenic. Okay, here also see the valency band, conduction band, energy level. Forbidden gap is quite narrow. Here the forbidden gap is quite narrow. So here semiconductors, semi means they are the between conductors and insulators. They can conduct electricity. By name itself you can understand, isn't it? So here energy, heat energy at room temperature is sufficient to move electrons from valency band to conduction band. Here what I said, a room temperature, the energy which is present at room temperature is sufficient to move the electrons from valency band to conduction band. So when the electrons are moving from valency band to conduction band, what happened? They can conduct electricity to some extent. Okay, to some extent. That means here semiconductors, they are depending on heat energy, isn't it? So the conductivity of the semiconductors can increases with increase in temperature. Okay, conductivity increases with increase in temperature. So this is the difference between conductors, insulators and semiconductors. So that's all for today's class. In the next class we are going to see types of semiconductors. Thank you children.